Hello everyone, I am the first author of this paper, Shizuyu. Now, let me introduce to you the work of our laboratory in the newly recruited ICCV 2025. I will present my report from the following 4 aspects. In sports video captioning task, there are generally 2 types of descriptions. 1. Commentary style, targeted at TV audiences, more detailed and longer in length. In addition to specific actions and participants, they often integrate rich background knowledge, such as, this goal is the player's NTH career score, or the team's NTH score this season. 2. Live text broadcast type, targeted at online users, more concise and straightforward. These captions deliver key events concisely, enabling users to quickly grasp the progress of the game without watching the entire game. Our research focuses on the live text broadcasting task in sports, exploring identity-aware video captioning methods. The goal is to accurately convey who is doing what within concise descriptions, enhancing practicality in domain-specific scenarios. To date, existing identity-aware sports video captioning methods can be divided into 2 categories based on how entities are represented in text: anonymous and identified. The core difference lies in the explicitness of entity representation. Anonymous methods, as the name suggests, replace real entity names with pronouns, role names, predefined IDs, or special symbols. While such methods can distinguish different entities and facilitate model training, they still fall short of practical needs. For example, audiences prefer James makes a 3-pointer over player A makes a 3-pointer. So, accurately recognizing and generating real player names is a key challenge for improving the usability and user experience of sports video captioning. The identity-based methods retain the actual names of entities and captions, making the generated descriptions closer to real-world scenarios and improving the completeness and readability of the text. A representative work is the Football Commentary Dataset Goal, constructed by the team of Professor Zhuanzi Li and Jie Tang at Tsinghua University. This dataset not only annotates who does what in events, but also integrates relevant background knowledge, such as match news and statistics of players and teams. Their method feeds both this external knowledge and video content into the model, generating commentary-style captions that include real entity names, thereby achieving entity-aware caption generation. In terms of knowledge enhancement, we conducted 2 studies. The first, published in Neurocomputing, is inspired by the fact that commentators usually know the lineup before a game. We use the participating players as game knowledge, candidate player list, and feed it into the model together with visual content, enabling the generation of text descriptions with player names. To support this task, we constructed the Basketball Video Caption Generation Dataset VC NBA 2022 for event-based text live broadcasts. The dataset annotates each video clip with video file ID, action type, text description, player images, and names, covering 9 types of shooting events. The table shows the statistical data of each event. Building on this, we further enhanced the model from 2 dimensions: architectural design and knowledge integration. We observed that events of the same category, e.g., 3-pointers, 2-pointers, often share common action paradigms. For instance, 3-pointers typically occur beyond the 3-point line with larger motion spans, while 2-pointers are mostly executed inside the arc with faster movements, especially layups often accompanied by sprinting actions. Meanwhile, drawing from the analogical reasoning principle in human cognitive psychology, humans tend to retrieve existing knowledge prototypes from long-term memory to facilitate the recognition and understanding of new observed actions or scenarios. Inspired by this, we introduced implicit visual scene knowledge into the model. Specifically, as illustrated, we first grouped video clips of the same action category in the training set by labels, calculated the mean value of video features for each group, and defined the resulting central features as implicit knowledge. This knowledge characterizes the typical paradigms of scenes and the boundaries between different scenarios, aiding the model in better distinguishing event categories. Meanwhile, explicit game knowledge, still the candidate player list, works in tandem with implicit knowledge, effectively improving the model's performance. From the above research, we can summarize 2 key points. 1. Traditional methods, datasets, and anonymous approaches struggle to support specific practical tasks. 2. Externally introduced knowledge is independent of video content. The model doesn't truly recognize player identities, but infers or guesses them through external knowledge. Thus, we need to develop visual recognition methods and construct a dataset library to support this task. Compared with the first version of VC-NBA 2022, our newly constructed dataset has the following improvements. 1. More video clips, 3977-9726. 2. More types of events. 3. Video clips in NBA Identity are in MP4 format with variable lengths depending on event duration, while clips in VC NBA 2022 are uniformly sampled to 72 frames. 4. All captions in NBA Identity are obtained directly from the live streaming platform without any modifications and have authenticity. 5. Captions include shot distance, more challenging and realistic. 6. Support more downstream tasks. To this end, we propose a player-centric multimodal prompt generation network for visual player identification and text description generation with player names. The red line denotes the training path, the blue line denotes the testing inference path, and the black line denotes the path shared by training and testing. At the training stage, obtain annotated key player bounding boxes and names via video IDs, and extract visual features using a pre-trained player recognition network. Feed player features and video features into the designed bidirectional semantic interaction module to enhance the association between players and video content. At the inference stage, since manual bounding boxes are unavailable in practical applications, use SportsMOT, developed by Professor Li-Min Wang's team, for automatic multi-object tracking, extracting detection boxes for all players in the video. Input each player's sequence into the pre-trained recognition network to obtain names and visual features. Then select top K players by confidence for bidirectional enhancement with video content. In the orange module, design learnable vectors to extract key scene semantic information from video features. Concatenate player features, video features, and scene semantics to form a multimodal prompt, guiding the language model to generate text descriptions with player identities. This is the pre-training diagram of our player identification network. Specifically, we use all annotated player sequences in the training set as training data, take player identities as category labels, and train the timesformer network to obtain a pre-trained model for player recognition. This is our designed bidirectional semantic interaction module, which models the semantic correlation between players and video content to achieve bidirectional feature enhancement. FO the decoder, we employed 3 different language models: GPT-2, Llama 3.2, and Qwen 2.5. Our LLMI-AVC achieved state-of-the-art performance on both our newly proposed dataset and the previously constructed VC-NBA 2022 dataset. This is our qualitative analysis result. It can be seen that the model not only generates more accurate player identity information, but also recognizes action types more precisely. Our contributions are as follows. 1. We propose a player-centric multimodal prompt generation network for LLM-based identity action basketball video captioning, LLMI-AVC, which jointly utilizes player identity features and contextual video information to guide LLM in generating identity-aware descriptions. 2. A large identity-aware basketball video captioning dataset NBA Identity is constructed. This dataset contains the largest number of videos among identity-aware sports video captioning datasets. Its captions cover 9 major events in the basketball domain. 3 extensive experiments on our NBA Identity and VC NBA 2022 datasets demonstrate that the proposed model achieves state-of-the-art performance without the need for additional knowledge assistance. In the future, 1. Fully utilize the player-related knowledge, such as player numbers and jersey color. 2. Distance evaluation module should be added. 3. Dataset needs to include more event types. We have listed the literature covered in the report. Those interested can take a look. If you have any questions, please feel free to contact us. Thank you.